look at more differentiation of trig functions, and we're also going to go on and look at logs and exponentials, and then we'll have a look at the chain rule and product rule and the quotient rule and see if we can do some work with that. Let's go in and have a look. Now, when we start having a look at trig functions, we've already defined some of these, so we don't need to worry too much. But if we've got something like, let's say, y equals the sine of x, we know that dy by dx of this is simply going to be cos x. So if we have a particular thing to work out and we're told we want to work out perhaps y equals, let's have sine 2x, and we're asked to differentiate that, then dy by dx of that is going to be, bring this number to the front, to cos 2x. In the same way that if I take something which is perhaps 2 cos x, then if I differentiate this, then what we're going to need to do is to leave that number where it is, and that's going to be 2 times differential of that, which is minus sine x. So that's simply going to give us minus 2 sine x. Putting both of those together, if I've got 2 cos 2x, then we would bring this number to the front, so that's going to give me here 4 minus 4 sine x. Let's try something, I don't know, something a little bit harder, I suppose, and we get something that looks sort of, let's go and make one up that doesn't look too horrible, I suppose. How about 3 cos 2x? So y equals 3 cos 2x. So when we start getting into these 3 cos 2x, it's going to be simply 3 times here minus 2 sine 2x, which is giving us minus 6 sine 2x. So they're not really that difficult to have a go at. These simple sines and coses don't really represent a major problem. We can get some nastier ones where we can combine all sorts of things. So let's go and for one here, which is y equals, let's have sine 2x plus cos 3x. So we'll just differentiate each of those separately. So our dy by dx here is going to be 2 cos 2x, and then we'll differentiate the other one separately, which is going to be here minus 3 sine 3x. And I hope you agree that they're not that difficult going through most of these sort of little functions, so they're not that difficult. They get more difficult in a minute, but we'll see what we can do about those. let's have a look instead then at the next one, which is looking at logs and e. Now, e is one of these peculiar things, and basically what we've got is, if I take a function which is y equals e to the x, then if I differentiate this, then I find my differential is exactly the same as we had. Now, this does cause a few little problems, but it shouldn't be anything that you shouldn't be able to sort of not cope with. So if we've got these, then simply we can play around. Let's take this, but we'll put now here, write it out just very slightly differently, and we'll say y equals e to this time to the kx. If I differentiate this, this becomes k e to the kx. Now that makes sense, and if we look at a particular function, let's look at an example here. Let's go for, I know, 4e to the 5x. So this is going to be, when we differentiate it, dy by dx is going to be 4 times, and then we'll bring down this 5e to the 5x, which is going to give me 20e to the 5x. The reverse of this is not quite so obvious. Y equals ln x, or ln as some people call it, log to the base e. The derivative of this, dy by dx, is here 1 over x. So let's see what we can try and do with one of these. So let's take not an example, let's just take some letters to play around with here. So let's have here let's try thinking of something. Yeah, let's go for ln of 7x. Okay, so if I want to try working out ln of 7x, then dy by dx here simply means that we're going to have to turn this into sort of something else we can sort of play around with. And what are we going to try and play around with ln of 7x is simply, it's going to be here, if it was ln of x, it's just going to be really very simple, it's just going to be 1 over x. So if I've got ln of 7x, well, it's 2 logs. So this, if we like to think about it, is going to be y equals the ln of here 7 plus the ln of x. Differentiate this, it becomes 0 plus this one, which is going to be 1 over x, which gives us 1 over x. And that tends to be surprising to people when they first start doing it. But it is a case of trying to think of these as basically separate logs. Let's look at another one. And if I take another example, let's have y equals ln of x cubed plus the ln of 5x. Let's think about what this one is. This is the same as 3 ln of x, and this one is the ln of x and the ln of 5. So once we've got this sorted out, and I seem to have an interesting thing here because I've got ln of x and 3 lots of ln of x, so that's actually going to give me 4 lots of ln x plus ln of 5. If we now differentiate this, then we've got here 4 times 1 over x plus 0, and that is going to give me 4 over x. I can sometimes understand why students don't like these. They aren't particularly nice, and they're not generally fairly easy to spot. And we can make these sort of basically worse because what we sometimes get are other numbers that you're expecting to try and do, and it doesn't seem quite obvious. So let's have a look at something that's not quite so obvious, which is like y equals here 4 times a third x. Now what we've got to try and do is we need to try and get this in a form that we can actually start playing with. Now what can we actually do with this? Well, we've got this is in the form of something like this is here a to the kx, and if I differentiate that, that's going to give me a to the kx ln of a. Now once I've got that idea, now we could guess that here a is going to equal 1/3, and here k is just going to equal 1. So substituting this into there, we can get dy by dx equaling 4 1/3 x ln of 1/3. So it's seeing these as logs, and while you're trying to do those, it's difficult to sort of necessarily work some of these out. So this causes a little bit of a problem with some of these. So let's try something a bit harder. Now let's take something that's not particularly nice, and I've got some sort of function of x. Let's have some function of x, and this is going to be e to the 2x minus the ln of something like x squared. Now, what do we try and do with this? Oh, let's put a number in there as well. Right. Let's sort this out. So this is still e to the 2x. This is minus, let's sort this one out, 2 ln of x plus some sort of number, 4. And then if I want to differentiate this, then we've got dy by dx is going to be, we just differentiate each one separately, so this is going to be 2e to the 2x, and then if I'm going to differentiate this, it's going to be 2 times 1 over x, which is just going to give me 2x, and I threw a number in there for good measure, it just disappears. And there is our derivative. They get easier. But where we start meeting some problems, which we met last time, we had to try and have a particularly nasty little function, and what we had to try and do was sort of work it out before we started and differentiate it. Now there's a way of trying to do that. So let's have a simple function which is going to be y equals something like 3x to the 4. Easy enough to differentiate that. But let's say I'm going to make it 3x to the 4 plus x. Still easy to do that. But now I'm going to make that to the power of 5. So our ways of trying to differentiate this could be to actually multiply that out, and then once we've multiplied that out, then to differentiate it. But there's an easier way, and that is using something called the chain rule. The chain rule says that dy by dx can be made by taking dy by some other function du times by another function du by dx. Now these will eliminate and we'll be left with dy by dx. But in the meantime we can try and do something with this. So let's see what we can do with this function. So what I'm going to do is I'm going to rewrite this function and say that y is going to equal this lot. Can't do that, so I'm just going to call that u to the 5, where u is going to equal 3x to the 4 plus x. Now I've got two particular functions. What we can do is we can differentiate each of these. So this is going to be dy by du, and that's going to be 5u to the 4. And what we've got is the other one, and the other one is going to be here, u is going to be equal to 12, so this is going to be du by dx, 12x cubed, and that little x is just going to give us plus 1. So writing this lot together, we can say that dy by dx is going to be these two multiplied by one another, which is going to be 5 u there times 12x cubed plus 1. And it's probably better I put that in brackets. Okay. Now I also happen to know that u is that, so dy by dx here is going to equal 5 whatever u was, 3x to the 4 plus x to the 4 times 12x cubed plus 1. Now sometimes we need to sort of resolve this a bit better and multiply these things out, but basically there's our particular function done. So we'll have a go at trying to see if we can solve a couple of these sort of problems, but let's throw in one of these as a sign and see what sort of mess that's going to actually cause us. So if I've got this here with signs in, it's going to give us a little bit of grief. So let's have a simple one here, which is going to be that, I know, y equals sine 4x. Now that is another way of writing sine x to the power of 4. So let's divide this up. So I'm going to say that u is going to be sine x, and that's going to give me u to the 4 for y. Okay, so let's differentiate each of these. This is going to be du by dx, and sine x becomes cos x, and here dy by du is simply going to be 4u to the power of 3. With our chain rule, dy by dx equals dy by du times du by dx. Substituting each of those, I've got 4u, which I already know, but I'm just going to write it out here, times cos of x. Let's put in what u is. So this is going to be 4 times sine x cubed, simply times by cos of x. Rewriting this in the form that we had it to start with, this is going to give us 4 sine cubed of x cos x, and there's our answer. So this function of functions, it's called, or as we might call it simply the chain rule, is really quite powerful system, and we use this really quite a lot. Where I find many students go wrong is what they do is they get rather blasé about it, and they just say, I'm just going to write down the answer. And yeah, you can do that, but sometimes they miss out bits and pieces. So I would advise, basically to start with, start writing it all out all the time, and gradually you'll get better at it. Let's choose a nice easy one. So I've got y equals 1 plus 2x here to the 7. So we look at this, we divide it up. I'm going to say that u is going to equal 1 plus 2x, and y is going to equal here u to the 7. du by dx, and students don't like writing all this out because it's an awful lot of effort, is going to give us 2, and dy by du is simply going to give us here 7u to the 6. And now, using the chain rule, dy by dx equals du, alright, dy by du times du by dx, and that's going to be dy by du 7u6 times my du by dx, which is 2. So I can resolve that easy enough as 14u to the 6, which gives me 14 times 1 plus 2x to the 6. Now, let's try one that looks perhaps a little nastier, and let's throw a sine and a cos in there, why not? So how about we get something like y equals sine x plus cos x, and we can do that to a power, I don't know, 3, and we'll see what we can do with this one. Now, where are we going to start with this one? Well, again, we're just going to use the simple chain rule to try and sort these out, and again, they're not particularly difficult trying to sort out where we're going to go and where we're going to start with. So I'm going to start with u is going to equal my sine x plus cos x, and y is going to be u to the 3. du by dx here, well, we'll need to differentiate these. So sine is going to become cos x, and cos x is going to become minus sine x, and my dy by du is going to be 3u squared. Using our chain rule, dy by dx equals dy by du times du by dx. So let's go and write that out. That's going to be 3u squared simply times cos x minus sine x. Let's go and put these in, and we've got here dy by dx is going to equal 3 times u, and u was sine x plus cos x here squared times cos x minus sin x. So it works, and the chain rule can be sort of quite useful for doing all sorts of manner of different things. Let's make my life a bit harder. Let's put some of those things together, and let's try something like y equals ln of sin x. Okay, same principle is going to apply. U here is going to be sin x, and y is going to be ln of u. So du by dx is simply going to be cos x, and dy by du is going to be 1 over u. We know from the chain rule that dy by dx, and this is what students don't like, is writing all this out, is dy by du times du by dx. So dy by du is simply going to be 1 over u times cos x. Let's resolve this. 1 over u is going to be 1 over sin x times cos x. Well, I would normally write that as cos x over sin x. And we know that cos over sine, well, sine over cos is tan, so cos over sine is cot x. And there, I've solved it. They're not too hard, are they? So let's imagine we have something a little bit more difficult, and where we come here is some sort of nasty sort of function. So let's see if we can try some sort of nasty function. Let's see what we can think of. Now, if we're going to go for one of these functions that's going to be sort of getting you to think about, it can be a bit more difficult to try and do some of these. So let's just try something. So let's try differentiating something nasty. I'll try a couple of these. So let's have y equals, how about sine squared 3x. Well, first of all, what does that mean? Well, that simply means the sine of 3x squared. I'm going to let u equal something
Yes,
like,
as a reminder, take a poison tablets.
I'm going to let u equal something nice and simple like sine 3x, and simply my y is going to equal u squared. And suddenly this doesn't look as difficult. Du by dx is going to be 3 cos 3x, and dy by du is going to equal here simply 2u. using our chain rule, dy by dx is going to equal dy by du times du by dx. dy by du is 2u times 3 cos 3x. And if I substitute back in for my u, this is going to be 2 times the sine of 3x times 3 cos 3x. We can get rid of those two, which is going to give me 6 sine 3x and cos 3x. I feel another nasty one coming on. Let's try what happens if we have y equals e, not to the x, but let's have this to the x plus 1. And what can we do with this one? Well, we can make this one just a little nastier, because that could be something like cubed. Right, so let's resolve this one slightly differently. I'm going to say that u is going to be x plus 1 cubed, and that y is going to equal e to the u. Now let's do du by dx. Now let's try and work out what this one's going to be, and this one here is, if you think about it, if I just even think what that one's going to be, that is going to be simply 3 x to the 1, and then we're going to have to try and do something with this. So this one here is also a problem that I've got to try and solve here. Now we could do this one, and we could do this one here as simply some sort of chain rule in itself. So let's look at what we could do if I gave you that one to do. So let's think about this one, and let's do this. So that would be the same as saying, well, I'm going to have du by dx. I'm just going to change this into going to be here, let's choose a different letter, J, could be V, could be anything else. So that's going to be V cubed, and I can say that V here is going to be x plus 1. So I'm going to do d, if I want to do this one, is going to be basically dy by dv is going to give me 2, it'll give me 3v squared, and this one is simply going to give me dv by dx is going to give me, when I differentiate that, x plus 1 is just going to give me 1. I know that here dy by dx equals here dv by dx times dy by dv. So that's going to give me 3v squared times 1, which is going to give me 3v squared. Put v back in, and we decided that v was that, so it's going to give me 3x plus 1 squared. So that is now what my du by dx is. And I was just going to cheat, I was just going to write that down for you, but now back to our other equation. We've got then du by dx is equal to 3x plus 1 squared, and I've got up here, I'm going to do this one, dy by du is going to be the same as when we did it, so that's also going to be e to the u, and then using the chain rule again, dy by dx equals dy by du times du by dx, and this is going to give us e to the u times here 3x plus 1 all squared, and we know that what we started with was here e to the u, so I'm going to write this out a bit more sensibly, I suppose, and I'm going to write this as 3x plus 1 all squared times e to the whatever the u was, and u was right back up there, my x plus 1 all cubed. Wow, that was some sort of sum trying to do that. So I did chain rule instead of chain rule. Now what we can do is go on and have a look at a slightly more complicated version of this, and this is called the product rule. Now the product rule says that dy by dx is going to equal u times dv by dx plus v times du by dx. So let's get an example of this sort of thing, and if we take an example, something like x squared times the square root of 3x minus 1, and that's what we're going to try and see if we can find the differential of. Okay, so these aren't really quite as bad as they seem, because all we've got to do is follow the basic rules of trying to work out what we're going to do. This of course isn't in a nice format, so let's see if we can get this in a nicer format. So this is going to be y times x squared, and then what we've got is this nasty bit, which is going to be here timesing it by 3x minus 1 to the power of a half. Now I've still got here a product, and so what I'm going to do is I'm going to do this simply as a product, and we're going to say that we're going to make u equals x squared and v is going to equal 3x to the minus 1, 3x minus 1 to the power of half. Now I've got both of those, what I'm going to do is I'm going to differentiate each of these. So I've got u and I've got v. I'm going to work out what du by dx is going to be. Du by dx is going to give me 2x, and I've got to work out what here this is. Now we can again see that this thing is not going to be that nice, because this also is one of those nasty chain rule things that we need to do. So I'm going to go off and I'm going to do that chain rule. So I've got here v equals 3x minus 1 to the half. Let's separate this. So I'm going to call this y to make life easier. I'm going to just say that we're going to have here u is going to equal here 3x to the minus 1, 3x minus 1, and I'm going to set y equal to u to the power of a half. Let's differentiate each of these. We've got du by dx, and this is going to give me 3, and I've got dy by du, which is going to give me a half u to the minus a half. Putting these together, dy by dx is going to be the chain rule, dy by du times du by dx. So this is going to be dy by du, which is going to be a half u to the minus a half times 3. That's going to give me 3 over 2, whatever u was, which is here 3x to the minus 1 to the power of minus a half. And that is what this thing was when we tried to differentiate it. So this is dv by dx. So now I can try and write out my product rule, and I've almost forgotten what that was. So let's go and have a look at this product rule. My product rule is going to be dy by dx is going to be u dv by dx plus v du by dx. Let's take each of those in turn. My u is going to be x squared. My dv by dx is that lot, so it's going to be x squared here times 3 over 2, 3x to the minus 1 to the minus a half, plus v, and v was all of that lot, which is 3x to the minus 1, this time to the half, by du by dx, and du by dx was 2x. So let's see if we can resolve some of this and see what we've actually got, so that we can try to sort of sort this out a little bit better. And I'm going to multiply these out. So I'm going to do x squared times 3. That's going to give me 3x squared over 2. And I then want to try and work out what else we've got. And what else have we got? I've just multiplied that by 3x to the minus 1 to the minus a half, plus I've got here 2x times 3x minus 1 to the half. Now that's going to go down the bottom, and so's that. I could perhaps multiply that lot out. And see what I get. So at the moment I see I've got 3x squared. I've got 2 at the bottom. I'm going to have that at the bottom, which is 2 times the square root of 3x minus 1. I'll just put it back in the same format that it had. Then I've got plus just simply 2x times 3x, the square root of 3x minus 1 to the half, which is, I've done that, I've just written it square root of that. Right, okay. Just thinking if I can try and resolve this any nicer. Yeah, I suppose I can put that back in there. That's going to give me then 3x squared plus, that would be 12x squared minus 4x all over 2 root 3x minus 1. That's going to give me 15x minus 4. Let's move paper up a little bit. So that's going to give me 15x squared minus 4x all over 2 root 3x minus 1. And if I do some work with that, I can take a factor of, well, just x out really, isn't it? So x into 15x minus 4 all over 2 root 3x minus 1. Ugh, horrible. Trying to see some of these things, not really very nice. We'll do one more. Let's suppose I've got y equals x times 1 plus 3x to the 5 again. what am I going to try and do with one of these? Well, what we're going to try and do is say that u here is going to be x, and I'm going to set v is equal to 1 plus 3x to the 5. That, of course, isn't going to be very nice, because I'm going to actually have to do that one by the chain rule. So you can see that we're getting various things here, so I'm going to go off and I'm going to need to do the chain rule again. So I'm going to say that y in this case is going to be 1 plus 3x to the 5. I'm going to say that u is going to equal 1 plus 3x, and y equals u to the 5. Let's now differentiate each of these. Du by dx is going to be here 3, and dy by du is going to be 5u to the 4. Put those together, so we've got dy by dx equals dy by du times du by dx, and if we do those, we've got 5u to the 4 times 3, and that's going to give me 15, whatever u was, which was 1 plus 3x to the power of 4. So that is what dv by dx is. Somewhere back here I had du, so I want to work out du by dx, and that's simply going to be 1. So let's now come back and do my product rule. My product rule is dy by dx equals u dv by dx plus v by du by dx. So let's substitute in for all of these things. My u was x, my dv by dx I've worked out here is going to be, so it's x times 15 times 1 plus 3x to the 4 plus v, which was right up here, which is 1 plus 3x to the 5, and I'm going to multiply that by du by dx, and I worked out du by dx was 1 times 1. So the hard bit then comes with trying to sort all this mess out, and what I've got is 1 plus 3x to the 4, and I've got, what I'm left with is $15x. So we've got that one. I'm going to take it, if I could take a factor of, yeah, I'm going to take a factor of 1 plus 3x to the 4 out of both of those, and if I take a factor of both out of both of those, I'm going to be left with 15x plus 3x plus 1 15x and 3x are going to be 18x, so it's going to be 1 plus 3x to the 4, and I'm left with 18x plus 1. There we are, there is our product rule, and you can see it's quite difficult, especially if they go and give you one of these chain rules to do in between, and then trying to get these things to factor out like I did with the other one. It's not that nice. So there we are, there's some of those. I'm going to give up at this point. I won't do the quotient rule today. I'm not going to have time to do that. So next time I'll start with the quotient rule. They do take quite a long time, and I'll have a look perhaps at some more difficult differentiation. So if you found that useful, then please subscribe and give us a thumbs up, and I'll see you next time on A-Level Maths topic by topic. Until then, stay safe. Bye bye.